On April 13th, 2029, something extraordinary will happen. A massive asteroid stretching nearly the length of 3 football fields will race past Earth at a distance closer than many of the satellites orbiting above us. Nothing this large has ever been predicted to pass so close to our planet in recorded history. For a few unforgettable hours, nearly 2 billion people across Europe, Africa, and parts of Asia will be able to look up and watch it with their own eyes. No telescope, no special equipment, just a bright point of light silently moving across the night sky. Its name is Apophis. Before you panic, here's the most important fact. Apophis is not going to collide with Earth. Scientists have confirmed that our planet is safe for at least the next century. But that doesn't mean the story ends there. Because as researchers continue studying this asteroid, they keep uncovering mysteries that don't fit the picture of an ordinary rocky space rock. And when Apophis makes its closest approach in 2029, our planet's gravity will pull on it with a force it hasn't experienced for millions of years. No one knows exactly how the asteroid will respond. By the end of this video, you'll understand why this close encounter has scientists paying such close attention and what they hope to learn from an event that may never happen again in our lifetime. Apophis will make its closest approach about 31,600 kilometers above the Atlantic Ocean. That is actually closer than the geostationary satellites that provide television broadcasts, weather forecasting, GPS support, and a huge portion of global communications, which orbit at roughly 35,700 kilometers above Earth. In other words, Apophis will pass beneath many of the satellites we depend on every single day. It will also fly by at only about 1/10 of the Earth-Moon distance, making it the closest known flyby of an asteroid this large ever predicted in advance. This isn't a tiny rock. Measuring between 340 and 375 meters wide, Apophis is comparable to placing 3 football fields end to end. Imagine an object as large as a skyscraper moving so close to Earth that millions of people can actually watch it glide across the sky without binoculars. Events like this are incredibly rare. And although there's no danger of an impact, scientists aren't focused on where Apophis is going anymore. Instead, they're asking a different question. What exactly is this asteroid? For years, astronomers have tracked its orbit with incredible precision. We know almost exactly where it will be during its 2029 flyby. What we don't fully understand is the asteroid itself. That mystery became even more fascinating after its discovery. When Apophis was first spotted in 2004, early calculations suggested there was about a 2.7% chance that it could strike Earth in 2029. While that number may sound small, for an asteroid this large, it immediately caught the attention of the scientific community. In fact, Apophis briefly became the highest-rated asteroid threat ever recorded. For a while, it was considered the most dangerous known asteroid in the solar system. Fortunately, as astronomers collected more observations over the following years, the calculations became far more accurate. By 2021, high-precision radar measurements had mapped its orbit so well that scientists confidently ruled out any impact with Earth for at least the next 100 years. Even the tiny possibilities once considered for 2036 and 2068 were reduced to almost zero. Today, its path through space is one of the best measured asteroid orbits we have. Ironically, that's where the real mystery begins. Knowing where an asteroid will travel is very different from understanding what it's actually made of. We've mapped Apophis's journey through space with remarkable accuracy, but its true nature remains surprisingly uncertain. And in 2029, Earth's gravity will perform a natural experiment that scientists have been waiting to witness. Attention has shifted from where is it going to what will happen when Earth pulls on it. The biggest clue came from a single measurement that didn't make sense. Apophis appears to be far lighter than an asteroid of its size should be. One of the most important properties astronomers measure is density because it reveals how solid an object really is. Apophis has an estimated density of only about 1.75 grams per cubic centimeter. For comparison, solid rocky material like the stone found in Earth's mountains has a density close to 3 grams per cubic centimeter. That difference is too large to ignore. The only reasonable explanation is that Apophis isn't one giant solid rock. Instead, a huge portion of its interior must be empty space. Scientists estimate that nearly 40% of its volume could consist of gaps between rocks rather than solid material. This makes Apophis what astronomers call a rubble-pile asteroid. Instead of a single massive boulder, imagine thousands of rocks, boulders, gravel, sand, and dust loosely gathered together. They're not held together by cement or solid rock. Their own weak gravity is almost the only thing keeping the entire structure intact. Think of it less like a giant stone and more like a floating pile of rubble drifting through space. That fragile structure means a powerful gravitational pull could actually reshape it. And in 2029, Earth is about to test exactly how fragile Apophis really is. This isn't just a theory anymore. Space agencies have already explored asteroids that behave exactly this way. When Japan's Hayabusa mission visited the asteroid Itatala, scientists expected to find a giant solid rock. Instead, they discovered something completely different, a loose collection of rocks, gravel, and dust barely held together by gravity. It looked less like a mountain and more like a pile of debris floating through space. Everything we've measured about Apophis suggests it belongs to the same family. NASA witnessed something similar during the OSIRIS-REx mission to Bennu. When the spacecraft briefly touched the surface to collect a sample, it didn't land on hard ground. Instead, it sunk much deeper than expected, almost as if the asteroid's surface behaved like a giant container filled with loose plastic balls. That surprising moment changed how scientists think about many asteroids. Rather than being giant solid boulders, many of them are fragile collections of rubble, and Apophis appears to be one of them. That discovery alone would make its 2029 flyby incredibly valuable. But there was another surprise. When radar observations captured detailed images of Apophis during its 2021 approach, scientists finally got a clear view of its overall shape. It wasn't round. It wasn't even the typical irregular potato-shaped asteroid. Instead, Apophis appeared stretched out, with two large sections connected by a much thinner middle. Researchers kept describing it with familiar objects. Some compared it to a peanut. Others said it looked like a dumbbell. The simplest description? It resembles two separate rocks gently pressed together. Astronomers call this kind of object a contact binary. Long ago, two independent bodies likely drifted together, touched each other at very low speed, and never separated again. Their own weak gravity has been holding them together ever since. This shape isn't especially rare. Around 15% of near-Earth asteroids larger than 200 meters have this same two-lobed appearance. But appearances can be deceiving because every contact binary has one obvious weak point, the narrow connection between the two halves. Think about any object made from two pieces joined together. If enough force is applied, where does it usually break? Almost never through the thick, strongest sections. It usually fails at the joint. That narrow connection is the weakest part of the entire structure, and that's exactly what concerns scientists about Apophis. During its close flyby, Earth's gravity won't pull equally on the asteroid. The forces acting on each side will be slightly different. That means the greatest stress may be concentrated right where the two halves meet. So the shape of Apophis isn't just interesting to look at, it may reveal exactly where the asteroid is most vulnerable. But its motion through space reveals another important clue. Most planets, moons, and many asteroids eventually settle into a smooth rotation around a single axis. Apophis doesn't. It tumbles. Instead of spinning neatly like Earth, It twists, rolls, and wobbles through space at the same time. Its primary rotation takes about 30.6 hours, while a second slower wobble repeats roughly 263 hours. Imagine throwing a football with almost no control. Instead of spinning cleanly, it flips, twists, and rotates in multiple directions all at once. That's remarkably similar to how Apophis moves. And this strange motion tells scientists something important. An object's rotation depends on how its mass is distributed inside. A perfectly solid, balanced asteroid rotates differently from one filled with empty spaces, loose rocks, and uneven material. So when astronomers observe Apophis's unusual tumble, they're not witnessing anything mysterious. They're seeing clues hidden beneath its surface. Its motion is revealing information about an interior that no telescope can directly observe. Recently, this has sparked countless discussions online. Some people claim the strange rotation proves that something inside Apophis is actively shifting. Many of the numbers shared on social media should be treated carefully because they aren't supported by strong scientific evidence. However, the basic idea behind those discussions isn't entirely wrong. A loosely packed rubble-pile asteroid is exactly the kind of object expected to produce an irregular, unpredictable spin. Its rotation strongly suggests that the inside isn't one solid piece, and that naturally leads to an even bigger question. What happens when a fragile, uneven pile of rubble passes extremely close to a massive planet? The answer involves a force everyone already knows: gravity. It's the same force responsible for Earth's ocean tides. Because gravity becomes weaker with distance, the side of Apophis facing Earth will experience a slightly stronger pull than the opposite side. That difference stretches the asteroid. On Earth, this effect moves oceans. On a loosely connected asteroid, the consequences could be far more dramatic. And because Apophis is constantly tumbling, different parts of its body will repeatedly move into regions experiencing the strongest gravitational stress. Earth won't simply tug on the asteroid once. Over several hours, gravity will continuously pull, twist, and flex the entire structure, almost like someone repeatedly kneading a ball of soft dough. So what do scientists actually expect to happen? Computer simulations built from thousands of virtual particles all point towards a similar conclusion. Apophis will almost certainly survive the encounter, but it won't come away unchanged. Its rotation is expected to shift enough for astronomers to measure. The spin could become significantly faster or considerably slower, and even the direction of its rotation may change. As for the asteroid itself, researchers predict only small physical deformations, probably measuring just a few centimeters. Most of those changes should be elastic, meaning the asteroid will largely return to its original shape afterwards. In other words, the most likely outcome isn't a catastrophic breakup, it's something far more valuable to science. A close-up look at how an ancient rubble-pile asteroid responds when Earth's gravity briefly reshapes its motion for the first time in millions of years. The most interesting changes aren't expected across the entire asteroid. Scientists believe they'll happen in one very specific location, the narrow bridge connecting Apophis's two large lobes. Again and again, computer simulations point to the same answer. As Earth pulls on the asteroid, the greatest stress builds up around that thin middle section. The pressure holding both halves together could weaken slightly, allowing one side to shift by a tiny amount relative to the other. Even if the movement is small, it could trigger something remarkable: landslides. Because Apophis is held together so loosely, even a modest change in its rotation may be enough to send rocks, gravel, and dust sliding across its surface. If that happens, layers that have remained buried for millions of years could suddenly become exposed. For the first time, scientists might witness an asteroid naturally revealing fresh material in real time during a single close encounter with Earth. Of course, one obvious question comes up: could Apophis actually break apart? Fortunately, physics gives us a reassuring answer. Astronomers use something called the Roche limit, a boundary where tidal forces become powerful enough to tear apart an object held together only by gravity. For an asteroid like Apophis, that dangerous boundary lies much closer to Earth than its planned flyby. Apophis will pass well outside that limit. That means Earth's gravity is expected to stretch and disturb the asteroid, but not rip it to pieces. So, scientists aren't worried about complete destruction. What they don't know is how much the asteroid will change, and that depends entirely on what lies hidden inside. You've probably seen dramatic claims online suggesting Earth's gravity could snap Apophis into two separate pieces. Some posts even claim one fragment could pass through a tiny gravitational keyhole, changing its future orbit and eventually putting Earth at risk. It's an exciting story, but the evidence doesn't support it. The idea isn't entirely based on fantasy. Scientists agree that the narrow neck is the asteroid's weakest point. They also know that contact binary asteroids can experience stress during close planetary flybys. That's the part grounded in real science. Where the speculation goes too far is assuming that stress automatically leads to a catastrophic breakup. Current simulations tell a very different story. Instead of cracking apart, Apophis is expected to flex only by a few centimeters before returning almost to its original shape. Because it never comes close enough to cross the Roche limit, Earth's gravity simply isn't strong enough to pull the asteroid apart on its own. Even under an extremely unlikely scenario where the neck somehow separated, both halves would drift away from each other incredibly slowly, only a few centimeters each second. Over several hours, they'd separate by only a small distance. That isn't remotely enough to send one half through the tiny gravitational keyhole that the asteroid's current orbit already avoids. When scientists combine all those extremely unlikely events together, the probability becomes essentially zero. So the conclusion remains unchanged. Apophis is not expected to impact Earth during this century. The real mystery has never been whether it will become dangerous. The mystery is how dramatically this close encounter will reshape it. And that's exactly what keeps researchers so interested. Here's something many people don't realize. Different scientific models don't all predict the same outcome. Not because the mathematics is uncertain, but because every model must make assumptions about the asteroid's hidden interior. If Apophis is more solid and tightly packed than expected, the flyby may produce only a slight adjustment to its rotation with almost no visible surface changes. But if its interior is weaker, looser, and filled with larger empty spaces, the results could be much more dramatic. Its spin could shift significantly. The narrow neck could experience measurable movement. Fresh landslides might transform parts of the surface. Entire regions never seen before could suddenly become exposed. Right now, scientists can't say which version is correct. The models only define the possible range of outcomes. The final answer will come from Apophis itself. In many ways, this asteroid has been keeping the same secret for billions of years. The flyby in 2029 may finally force it to reveal what's hidden beneath its surface. If Earth barely changes it, we'll know the asteroid is stronger than it appears. If Earth noticeably reshapes its motion and surface, we'll learn that its interior is much weaker and more fragile than expected. Either outcome teaches us something completely new. That's why no computer simulation can completely solve this puzzle ahead of time. Sooner or later, the predictions have to give way to real observations. Scientists don't just need to calculate what might happen, they need to watch it happen. And that leads to an even more exciting question. When Apophis makes its historic flyby, who will be there to witness one of the rarest natural experiments our solar system has ever offered? For almost every close asteroid encounter in human history, one thing has always been missing: a front row seat. By the time we discovered most near-Earth asteroids, they had already passed by, leaving scientists with little more than distant observations. But April 13, 2029 will be completely different. This time, humanity won't simply watch from Earth. We'll be waiting for Apophis in space. One of the spacecraft preparing for this mission already has an incredible history. NASA's OSIRIS-REx became famous after traveling to the asteroid Bennu, collecting material from its surface and successfully returning those precious samples to Earth in 2023, the first asteroid samples ever brought back by the United States. Instead of ending the mission, NASA gave the spacecraft a brand new purpose. It has been renamed OSIRIS-APEX, and its next destination is Apophis. Its journey has been carefully planned with extraordinary precision. The spacecraft will arrive shortly after Apophis sweeps past Earth, using our planet's gravity as a natural slingshot before catching up with the asteroid roughly a week later. Once it reaches its target, OSIRIS-APEX will spend about 18 months studying every detail it can. It will map the surface, analyze its composition, monitor its rotation, and search for changes caused by Earth's gravitational pull. But perhaps its most exciting experiment comes near the surface itself. The spacecraft will descend to only a few meters above the asteroid before firing its engines downward. Those engine blasts will blow away loose surface material, exposing fresh layers that have remained hidden for ages. After spending years wondering what lies beneath the surface, scientists will finally get a direct look at material that has never been exposed to space in modern times. And NASA won't be working alone. The European Space Agency, together with JAXA, is developing another mission called RAMSES. Its objective is just as important, but very different. Rather than arriving after the flyby, RAMSES is scheduled to reach Apophis months before its close encounter with Earth. That timing is critical. It will study the asteroid while it's still completely undisturbed. Then it will remain alongside Apophis during the flyby, allowing scientists to compare the asteroid before and after Earth's gravity acts on it. For the first time in history, we'll have a detailed record of how an asteroid changes during an extremely close planetary encounter. In other words, this won't just be an observation, it will be a natural experiment performed on a real asteroid. Yet the largest observing network that night won't be made of spacecraft, it will be made of people. As Apophis races across the night sky, nearly 2 billion people throughout Europe, Africa, and parts of Western Asia should be able to see it without telescopes. A small moving point of light will slowly travel across the stars, reminding everyone that a massive asteroid is passing closer than many satellites orbiting Earth. For once, the public won't learn about an extraordinary space event after it happens. Millions of people will experience it live. Meanwhile, observatories around the world will be focused on Apophis from every possible angle. Powerful radar systems will bounce radio waves off its surface, producing detailed measurements of its shape, rotation, and any subtle changes caused during the flyby. Optical telescopes will carefully monitor tiny variations in brightness that could reveal fresh landslides, newly exposed material, or changes in its spin. Combined with data from both spacecraft, scientists expect this to become the most thoroughly observed asteroid encounter ever recorded. Almost nothing will escape measurement. And that's exactly why this event is so valuable. Because Apophis isn't important only for what it can teach us about itself, it may teach us how to defend Earth one day. Somewhere in the future, another asteroid will eventually appear whose path really does threaten our planet. If that day ever comes, humanity's ability to protect itself will depend on understanding one crucial detail: what's happening inside that asteroid. A solid rock and a loose rubble pile respond very differently when struck or pushed. Without knowing the internal structure, designing an effective planetary defense mission becomes much harder. We've already seen evidence of this. In 2022, NASA intentionally crashed the DART spacecraft into the asteroid moonlet Dimorphos. The goal was simple: change its orbit. The mission succeeded, but the biggest surprise came after the impact. Instead of behaving like a solid rock, Dimorphos released an enormous cloud of debris. That escaping material created extra thrust, pushing the asteroid even more than scientists expected. Its loose internal structure completely changed the outcome. A dense asteroid, a fractured asteroid, and a rubble-pile asteroid all react differently to the same impact. That's why Apophis matters so much. Its close flyby offers scientists a rare opportunity to study a rubble-pile asteroid under natural gravitational stress without having to create the experiment themselves. The knowledge gained could one day become essential if humanity ever needs to prevent a real asteroid impact. So where do things stand today? After decades of observations, Apophis has become one of the best-tracked potentially hazardous asteroids ever discovered. Its orbit is now known with remarkable precision. Current calculations show it poses no impact threat to Earth for at least the next century. Yet despite all that knowledge, one major mystery remains unsolved. No one truly knows how its interior is built. Is it tightly packed? Is it mostly empty space? Or is it an extremely fragile pile of rubble barely holding itself together? In 2029, Earth itself may provide the answer. Scientists will carefully measure every change in the asteroid's spin, surface, and overall structure. Those observations will reveal more about Apophis than decades of distant telescope studies ever could. Of course, science always leaves room for uncertainty. Researchers continue monitoring the asteroid because new observations can always improve our understanding. But that uncertainty isn't about a hidden doomsday scenario. It's simply about learning the fine details of an object we've never been able to examine this closely before. Over the next few years, every new observation and every spacecraft mission will sharpen the picture even further. Then finally, the waiting will end. On April 13, 2029, the largest asteroid ever predicted to pass this close to Earth will make its historic flyby. The encounter isn't expected to threaten our planet. Instead, it will answer one big question scientists have asked since Apophis was first discovered. What is this asteroid really made of? And for one unforgettable night, the world won't just read about history, it will look up and watch it happen.